Where's up, people? How's it going? We'll start the session in about 2 minutes time, waiting for a few people to join. Today's session is going to be a little bit shorter than you guys expect, but we're going to be primarily looking into something called as callable classes and what exactly are these used for, and another important topic called as typedefs. And typedefs are pretty much new to Dart and new to any programming language. So we're going to be discussing about all that in today's session. I'll start in about a minute or 2 minutes time. I'll wait for people to join and we can get started. Mhm. Hopefully my voice is better. I'm pretty closer to the mic this time, and hopefully this voice is better. We'll know about this in a minute's time. All right, so let's get started. All right, here I am. Hello. So we're going to be primarily looking into the concept of callables, and in particular, it's called as callable classes. And what exactly do these things do, and why are they required in Dart? I planned it for an hour session, and if you guys finish it in less than an hour, we can have a discussion around it in depth. But there's the concept of callables is very new to Dart, but it kind of got picked up from Python. Python has this amazing way of implementing something called as an operational overloading, where you can overload the operation that a normal class can do. For example, let's say that you have a class, and this class has an basic functions, like you want to do a toString to it. You can define a toString to the class, and you can override the method, and you can override the operation in itself. And that's pretty famous in Python. So what the Dart picked up from that was to do something called as the callable classes. Callable classes in particular, these kind of like help you to just define a class and call it like a function. There is no need to do anything more than that. So even before we get into that, I just want to do a quick I should say I want to do yeah, I want before we begin. Yeah, so we're going to be looking into, before we begin, I just want to give a brief explanation of what we have been seeing so far, since I know that the last session was streamed five days ago. I'm not sure. Yeah, so 5 days ago we looked into the concept of asynchronous functions, and in particular we looked into something called streams. And the streams in particular are very useful, because we looked into why these are called as streams in first place, and on top of that we also looked into why these are specifically used along with the concept of generators. And that's what we did so far. So I'm just going to give a brief explanation to that so that we can continue on from where we left off. In case you guys are continuing from there, you can just get a better understanding. So the concept of streams are very simple. Think of streams basically as the YouTube stream that you're doing right now. That is a basic sender here. The sender is sending some data to an ingest server, which is called as the YouTube ingest server, and ingesting some data into the servers. And these are not binary data, so right? These are not like data that are separated by some time. These are continuous data that keeps on going. This is like a water pipe. Now water flows through a pipe. We don't say water travels, or we don't say water is going from a point A to point B. There is no one droplet of water. It's probably, you cannot calculate water, right? You just calculate it in terms of liters, where you do not have a discrete value to it. It's always continuous. Similarly, the streams are continuous amount of data, and these continuous streams of data is going from a point A to point B, and from that the YouTube ingest server is pointing it, and it's kind of like recording or even stitching it to a video that you guys are seeing. So this is the whole process behind a YouTube ingest and YouTube streaming, and that's what we looked into in the previous session. So exactly what do these streams do and how you can create these streams. That was the whole topic behind previous video. So hopefully yeah, All right. There's a couple of things that you guys need to know when it comes to streams. The first topic is that it's going to be very very useful when you are, and streams are pretty new to Dart itself. Um, you can think of streams as still a discrete amount of data flowing from a place to another place. In theory, it's kind of like a continuous data flow, but in practice, you might think of it as a basic function that is basically doing everything that you want to do. So that's the whole idea behind streams, and that's what we looked into in previous session. And we also looked into something called as a stream controller by the end of last session. We also even implemented a stream, and we saw how to create streams. Basically, streams you can think of as an async generator, right? So we just mark it with a star, and this was the whole topic for last session, and we kind of looked into it in depth way. So if you guys want me to do another video session on that, I can do it probably to clarify any doubts, because I did get a lot of questions on that. So I can clarify doubts on that in another session. But for today's one, I'm going to be primarily targeting the concepts of callable classes. Callable classes are very very useful. You can use it in a lot of places, and Dart does a very good job. And that's what I'm going to be primarily concentrating on. Right. All right, let's move to callable classes. The concept behind callable classes is it's a simple way to call a class like a function. That's the whole idea behind it. Now, why do you want to do this first of all, right? Why do you want to call a class just like a function? You can ask me like, we already have functions inside classes. Like, why do you want to call a class like a function? Now, let's take a simple example. You are creating a huge function. You are creating a huge program. You are creating a program to probably uh, continuously find out what are the informations that somebody is sending to you. Like you're doing a chat application function, right? This chat application function is continuously going to be sending information. It's going to be stored in some place. It's going to be moving from a point A to point B. There might be millions and millions of users, and you need to probably connect every user to it. And there's a class that is primarily targeted to doing that. Let's say that you want to do something like a class that is going to have information like username, what IP it is originating from, and what is the message that this person A is trying to send to B. This is going to be the whole idea behind a chat application function. Now you want to you want to create a mechanism where you want to log all this information. Let's say that you are a very you are not WhatsApp. You are you don't have an end-to-end encryption attached to it. You are a very basic chat creator where you want to kind of log all this chat information, like you want to log the username, you want to log the IP address, so that it stays in a log, which basically means that it stays in kind of an mechanism to store all this information, so you can read it later. If you want to debug something, you can do it. So this is what you want to do. So what you're trying to do is to basically print all the username and IP, and every time you want to print this, you'll probably say, for example, let's call it as class A, right? You'll say A dot username, right? And you will say A dot IP, and you will say A dot message, and this is where you will print it, right? And also on top of this, you need to have the A instantiated, basically meaning you should have an object of A, and only then you can print all this information. This is kind of like what you will usually do. But what this call class will do is that it will give you a very easy mechanism. As soon as you've instantiated an object, right, you can directly say object of, you can just call it, and it will pretty much print it for you. And you can just basically calling it like a class. Instead, you're just calling it as a function. You can directly do this call and it will automatically print all the information for you. And this is possible by overloading the operation called as call off. Now, call off is the operation that is responsible for attaching a function like notation to a class, and that is what is going to be behind the scenes doing all the work for you. So that's basically what the callable classes are for. It's kind of a new idea behind Dart. And the in tomorrow's session, I have already another session planned for tomorrow in the morning. You learn more about how Dart is trying to run everything, basically like how different it is from your usual programming languages like Python and Java, where the operations of the ideas behind threading and multiprocessing, all of that is completely different in Dart, and that's why they wanted to have a different mechanism of doing this callable classes as well. This is very famous in Python. You have something called as toString. You can overload all the internal methods by kind of like saying toString. You can overload this, and every method that starts with double underscore is kind of an internal private method. You can still override it, and this is pretty much the idea behind Python. That's why it's one of the most used programming languages, because you have flexibility for everything. But in this one, we have access to the call class, and this call of function does basically helps you override the whole idea behind this bracket itself. Now you might have thought, like, what will happen if I put a bracket? Like, what is happening behind the scenes? As soon as you put these two brackets, this is some calling a method called as a call method, and this call method is internally invoking the compiler, and the compiler is doing everything for you. So we are basically taking this layer, the first layer, second layer, and third layer. We are even touching the second layer. That's the flexibility that is kind of giving us. So that's what we are going to be seeing in practice, like what and how to do it. And that's another important point here. So you are saying that associated with objects, usually if you think of a class, you'll often associate with the class with an object, right? And you don't have to associate with an object anymore. You can directly go and start writing or overriding your call method, and you have your class being called as a function. So that's the whole idea behind callable classes. So I'm going to be like showing you guys an what do you call it, as a code example in about a minute's time. So I'm still thinking that this whole idea behind YouTube streams sending out notifications, it's kind of botched, because I don't get any notifications, and that's why I think a lot of people didn't join. But let's figure out. All right, so I'm just going to be waiting for some people to join before I start writing the code examples as such. So let's do that, and I'll come back. Yeah, as the name suggests, this is actually the mechanism to print information in a much better fashion. So what we did quickly, I'll just do a summary. What we did was to use the string call. The call is the function. This call function is now returning two information. One is the name and the number in a stringified fashion. So just if you put this, it means a string, right? So that's why we have the return type also as a string. And the stringified function is now being taken by just doing something called an object of call. The object of call will pretty much take the information and just print the information, and this will be very useful. We are looking into the logger as a function, or logger as a utility. So this is a very useful one if you guys are interested to dig deeper and understand more about logging and loggers, and I'll definitely do a session on it. So just to drop a comment down below and I'll be able to know about it. So yeah, this is the first concept I wanted to cover, which is the concept of callable classes. And you will see that creating the callable classes, you need to make sure to keep in mind that this is not a constructor, and constructors are, as you know, has the same name as the class name. This is the constructors are for basically taking the value inside a class for creating an instance of a class, nothing more than that. So don't get confused with the idea behind constructors. Rather, you need to think about them as a mechanism to have or print values, right? Just for the use or overloading the call of a function is for just logging purpose. At the max, it's for logging purpose, nothing more than that. And also make sure to not overuse it, um, because you might tend to have a lot of different utilities to it, right? If you are trying to create something that is not going to be very useful unless you are going to be and other than this logging purpose, don't overuse it. And that's pretty much what I wanted to cover in the first section of this session. So creating callable classes is very useful, and I'll just switch to the Typedefs. Typedefs are very useful, and these are actually going to be highly sought after, especially in Dart, and you can even think of the Typedefs in any other programming language as well. So that's what you're going to be doing in about a minute's time. So let's see how many of you watching this session right now have any experience with Dart, or have you seen me before using Dart. So if you did use Dart before, just drop a comment so I'll know about it. And for those who do not know anything about Dart, do not worry, we have a lot of videos on it in this channel, so check them all out and we can continue on learning. All right, let's hear it from all the people who are on watching this stream right now. I do know that I started this stream a little bit earlier than usual. Probably that's why you guys did not get the notification, but that's pretty chill, right? Let's get moving on. All right, so let's get moving on. I'm going to be talking about Typedefs in about a minute's time. So I just want to know before from everybody who's right now live, how many of you have experience with using Dart as a programming language, or any other programming language for that matter? If you guys have a understanding of JavaScript or Python or Java, let me know in the chat so I do know like what do you guys want, so I can give you a much better way to relate to it. Hey everyone watching live, just want a quick note, like what do you guys use, like what is the language that you have learned so far? Do you guys know C++, C, Java, Python? What is your favorite programming language so far, so that I can know that this is your favorite programming language? And you can just pick up Dart if you're good with JavaScript. If you can pick up Dart if you're good with Python. Doesn't matter if you're starting for the first time to learn a programming language, you can use this programming Dart as a programming language as well. So let me know in the chat like what is your go to programming language, or what have you learned so far, so it's easy for me to do sessions around that, and it's easy to pick up concepts with it. All of these things that you're learning right now, right, especially the call as a callable class and all of that, these are available in all the programming languages in some form or the other. So it's not like something very new that Dart is involved or released, but you can think of them as an available mechanism in all of the programming languages. But you might know about it, some people might not even learn about it, but Dart as a programming language is giving it easy for us to consume. So just let me know in the chat like what is the programming language that you guys are using, at present, like what is the language that you're learning from. I don't know, a lot of you guys are watching many of the streams that are coming live on this channel, and you guys must be following one of the educators pretty closely. So what is the programming language that you guys are using at this point of time? All right, so I'm gonna get moving on. I'm pretty sure that you guys are watching this stream, but if you guys have any questions, just drop them in the chat section. So I do know that you guys have these questions. So I'm gonna get moving on to the next concept of type defs. And type defs are very useful, like I said, in Dart, and not just in Dart. In any type of programming languages, you will have some form of the this or the other. And type defs in Dart particular is a simple way to create your own data types. That's great, right? You have four main data types: your strings, your integers, your doubles, and your boolean values. And the type defs is a mechanism to create your own data types, right? Own data types, when I say, it's meaning to, you can even create something called as uh, Unacademy as a data type, and you should have defined it. You could even have created something called as a coder monk as a data type, and you should have defined it. And it's very famous in Dart, and also not just in Dart, it's also famous in Java, if I'm not wrong. You can create your own data types and use it. And if you see in particular with Python, it's pretty similar to the concept of enums in Python, but also very useful if you know about enums in Python. Enums in Python do have some other extra usage, but in particular with typedefs and Dart, you have an additional usage of creating your own data types and also using it in functions and all of those such. So that's what you're going to be doing. And one of the most important things to remember is that it adheres to the base data type. You should always think about this as basic data types. So it should adhere to all the rules that are around a base data type. Like if you define a string and if you give it a different name, it should still be a string. It should have all the properties of a string. You cannot define a string as a base data type and have integer operations on it, which is not possible. So that's what I'm trying to say when I say adhere to the base data type standards. And you should also make sure to you can also use in any place, just like a normal data type that you would already have used. So we're going to be seeing about how to create type defs in a minute, but let's quickly look at what are the different use cases that these have. So let's say another example, right? You have a huge chat application that you're creating. This chat application has to have its own data types. Basically, like let's say that you want to have mechanism to store information like this. Like you want to store username, you want to store the IP of the chat where it originating from, and the message into a simple single data type. But this is not possible at this point of time, right? You cannot store three different values into a single data type. You can put it in string, you can put it in list of string, you can put it anywhere. That is not possible. But if you have your own data type created and you tell that this is what it should be of this format, I want to store it in this format, then it is possible. So basically creating your own data type and giving it some properties, like this is the three values that you want to take, and it should stick to some forms. So like it should be a string, and IP should be also string, and message should also be a string. And this is what you are trying to define. And when you want to define your own basically own values for data, and creating your own data type at this point of time, so that's pretty useful. And that's what we're going to be seeing in a minute's time. Take a quick break and come back, and we'll see what exactly and how exactly you can create your own data types using the concept of type defs or type definitions. You can define your type definitions, and there's a lot of different use cases associated with it as well. So I'm going to be giving you a code example for that, and we will see how useful it is. All right, let me take a quick break and come back. All right, I'm back and we're going to be looking into the concept of creating type defs right now. So even before we begin and understand how to create a type def, you need to understand few important things with it. And yeah, we'll start with creating a type definition of our own. Go back to your Dartpad and you can start doing everything inside your main block. And I'm not going to be pretty much explaining most of the information here, but I'm just guessing that if you guys have any doubts, you'll definitely ask me. And the syntax for creating a type def is pretty simple. You just need to use the keyword, which is the type def, and you can just define what is the name of your type of your own create data type. Let's say I want to create a data type of the name CoderMonk, right? And that's my YouTube channel, so you guys can check it out. CoderMonk is going to be my new data type. I'm telling that this CoderMonk as a data type should be of list of integers, and it should have the properties of everything that a list of integers has. It should have the property of subscription, where you can just say subscripting to a specific value, which is, if I say of 0, it should bring out the value in of 0 and should have all the information associated with it. So type def CoderMonk, and I'm saying it should be of list of integers, so it should also be adhering to the list of integer and not a list of string. Next step, I'll say that I can directly create a value of saying, for example, CoderMonk, and give it a variable. I'll just say cmem. I can directly now, okay, my volume is not less. Anyway, so I can now say CoderMonk, which is going to be my data type, and I can directly say that the variable name is cm. I'll now say, instead of calling this a list of integers, I'm saying just CoderMonk. So this is actually getting type defined here. I'll just now directly define the values 1, 3, 5, 7, something like this. And this is basically what the type definition does, and that's what you're going to be checking out in this code example. So just open your .pad.def, which is right here, and inside your main block, start writing all the information, right? Just say, for example, in this block, let's, if you want to have this, I mean, I'm not very specific about it, so let's remove all this out and we'll just do something like this: print defining the first type def. In this section now we will say defining the new type def. I'll go here, I'll define my first type def. So the syntax is type def. As soon as you put it, will turn green. If it turns green, you can be sure that it's actually a keyword, and that's what we're going to be looking into. So type def space, I'll just say here the CoderMonk, which is going to be the name of my data type, and should have all the properties of a list of integers. So this is the basic explanation, this is the basic definition of it. So just saying of int is throwing error saying the comparison expression can't be an operand of another expression. All right, so this is also one more important thing that you guys need to know. The type defs are new ones that are defined only after the version 2.1.3. so we need to check if the version here is adhering to that. It says that undefined name type def. Why does it say undefined name type def? Expect let me check now. All right, I'm going to quickly check why this is throwing this error, because it's a very important one to check. All right, I guess this is the issue. Now, what you need to do is to define type defs outside the main block. So type def, I'll call it as coder monk. I'll say list of integers, and now this will be accepted. And this is the issue that one thing that I wanted to talk about. So this is going to be a problem. I mean, like, this is not a problem as such. This is actually a new feature wherein you can't define a type def a local to a method. It should be common to all the methods, and that's why they wanted to make it global. So when you define something outside the main block, or if you define something outside the function definition, it becomes global. And this is the type def that you have defined. So when I say typedef coder monk is equal to list of integer, I'm basically saying that coder monk will now be acting as a data type by itself. So I can now define my typedef here. I'll just say coder monk. I can now give it a variable. I'll just say call it a cm, and I'll just show you the final ones. And I can now define the values inside it, right? I'll just say 1, 3, 5, and 7. So basically that we go, we have the function definition. I'm sorry, we have the variable declared, and the variable is cm, and the variable now has the values 1, 3, 5, and 7. And there we go, we have your new type defined, and you can just do all the properties. You can now access all the values similar to how you will do in a list of integer. So you can say cm of 0, and it will print the cm of 0, and you can say print cm of 1, and it will print the value cm of 1. And as you can see, it is adhering to the base data type that you defined as. This is the base data type, right? The list of integer is the base data type, so it's actually sticking to that, and it adheres to all of that. And that's very, very important ones that the type defs provide us with in this example. So we have now the whole thing defined, and this is the base of type definitions. And you can ask me, like, why exactly do I need it? I'll show you guys an example in another 5 to 10 minutes time, where you will understand, or where you will see for yourself how a whole application has been defined. And type defs are very, very useful in Flutter in particular. You will see a lot of type defs present, and you will see that all these type definitions are pretty much used in a function definition. A function can be given a name, and the function itself can be defined as a data type, and that's also very, very useful. So just see now for ourselves. I'll run this program, and we'll see how this is very useful and how you can create it. So it's pretty much printing it, right? 0 and 1. Let's say you want to now or do some other things, like you want to, instead of just accessing the values, you can even access information just like how you will do with a list of integers. And that's the use of this. All right, so this is the base explanation. We have seen the base explanation done successfully, and I'm going to be showing you guys how you can pretty much use type defs within a function definition as well. Now, function definitions are the whole idea behind type defs. All right, so this is what I'm going to be looking into. We can even be used, it can even be used to define a function as a type def for easier passage. So like I said, we can even do a type def with a function name, and the function name can even be used inside as a data type. So I'll just show you guys how that is very, very useful. So you're going to be doing some code now. We'll be writing some code, and by end of that, you will understand how useful a type def function can be. And like as usual for the callable classes as well, you can even go around without using that, but you'll see for yourself how it is very, very how easier it can be. So what I'm going to do is to create a function, and I'm going to be calling this function coder monk again. So let's, for the purpose of this example, I'll remove this one. So we'll remove this as well. Right, now go here and define my first type def function. I'll just say type def as usual, and we'll just call this as coder monk, the function, right? I can now pass values inside it just like a normal function. I'll just say int a, int b, right? and finish this. So that's pretty much it. You don't have a function definition to it, just the function declaration. That's pretty much it. The next thing I'm going to do is to go back and try to create another method, and this other method is a normal method. I'll just have it as void compare values, and the first variable it's going to have is integer a, integer b, and now I can say coder_mong, which is the function itself, coder_mong of function. So you are now creating a typedef. You're just saying this whole function itself is actually a variable. And what is exactly the use of this? You're basically passing the function definition inside, and you're basically creating the whole thing around it. And that's also a very useful way of probably you can think of it as a very useful way of creating data flow from one point to another, where you don't have to always define the function name. You needn't have the function created every single time for it to flow from one point to another. You can have the function itself as a data type, and you can directly define all the things that you want to do inside it. So I'll just you can do anything inside it. You can now say print a, print b, and you can say function of a comma b, right? As you can see that this function is a coder_mong, and this coder_mong is what you've defined here, and you're just directly calling this. That's how useful it is. And let's say you have a definition inside it, you can even do a lot of things associated with it as well. So that's the whole idea behind typedefs as a function. So I'm just going to be showing you guys an example that is already defined, and it's very famous example when it comes to typedef functions, and you will see for yourself like how useful it is. So let me open that function for you. All right, this is actually a very famous example, and I'm not sure how many of you guys play the League of Legends game, and this is running in a simple, you can think of it as running in a simple way. It's a Flutter example, and as you can see that it's doing a lot of important things. You can see that it's able to give us this smooth movement, and all of these are basically the same functions. It has a different name obviously, and it's actually redefining all the operations that are available as part of a function, and is giving us that information. So let me try to close this whole thing so you can see for yourself how this example is running pretty wild, right? What do we have? We have two important typedef functions. One is the page change to callback and page select callback, and these are basically functions that take the page number and the index of it. And where exactly are these used again? Right here. So instead of just defining the function every single time, you have a variable for it now. On page change will directly define that it's going to be calling this function, and the on selected item will be calling this function, and that's whole idea behind it. So just saying this by typedef is a function, and this function is taking just the parameter page. Now let's see how this variable is now being used again. So just say page callback, and also right here. So it's basically becoming a variable on itself, and you'll also see that widget dot on page changed of current position. You're basically not doing anything complex, you're just storing the information just for the purpose of doing this cool animation. So I'm just doing a scroll on it and just doing all these movements, and it's pretty much very useful thing, just because we have a typedef present here. And this is one of the famous examples that is always quoted all the time to show to you guys like how useful this typedef can be. And you can even do away without typedef. You can even create this whole animation and things without a typedef, but it is reducing the amount of information that you already need to know, and it's actually reducing the amount of code you need to write just because you have a typedef present. So that's pretty much it, guys. So I just have completed all the ideas behind typedef and what are the additional things that are present. And one more important thing is you also want to make sure to is to again use the typedefs efficiently, not clutter your whole page and not clutter your whole thing. And it's also important that you keep in mind that typedefs, as the name suggests, are for defining data types only, nothing more than that, nothing less than that. So don't do anything outside the concept of type def, which might pretty much hinder the your program. Type defs should be used as minimal as possible, and it's not important to always use type defs. You can even have just define everything by the base data of it itself. Nothing's going to change much, right? So that's what I really wanted to cover. So I'm just going to wait for another couple of minutes, so probably another 2 to 3 minutes of time, so to see if you guys have any questions. And if you do have any questions, I'm going to answer that, and I'm going to be finishing this stream in about 3 minutes time. So I'll see you guys probably. Wait for some questions to pop up, and if there aren't any questions, I'm going to be finishing this stream. So tomorrow's session is going to start at 11:30 a.m. IST, which is Indian Standard Time. I'll probably be discussing the most important concept of isolates and why isolates are very important, and how the Dart programming is doing a great job with completely doing all the concepts of parallel execution and threading. Parallelism and threading is something that you will see a lot of times. And how the your usual programming languages like Python, your Java, right, all these are trying to call the CPU to execute parallelism and threading, but Dart on the other hand is using the concept of isolates, and how isolates are pretty much using the or pretty much used for pretty much doing the parallelism threading concept. So these are not running again with a simple way of CPU. Not just CPU will again have access to a shared memory, right? Shared memory, that's the whole idea behind threading. And parallelism on the other hand will have its own shared memory or own memory heap. But isolates on the other hand is doing something different, pretty much drawing a lot of concepts from Python, how Python executes things, but it's also having its own shared memory heap. So I'll talk about more of that in tomorrow's morning session, so make sure to stick for that and watch me there. So I'm going to be finishing the stream right now. All right, as usual, just another important note, check me out on Unacademy as well, and you can just find me on Unacademy under the name Baradwaj, and you will find that you will find how to take a lot of sessions in Unacademy platform as well. So just go to unacademy.com and you can check me out there, and you will probably also have access to all free classes and free live classes. You don't have to pay a dime. There are a lot of free live classes running, so you can just access that by using my activation code, which is CoderMonk. When you use the activation code CoderMonk, you can even unlock all the free classes, right? And also this is my YouTube channel, so check me out in my YouTube channel, and I'll probably be doing a lot of sessions there as well. So if you guys are interested, I do post a lot of sessions on OpenCV and machine learning and a lot of cool stuffs around that as well in my YouTube channel. So check me out on YouTube, check me out on Unacademy. I'll probably see you guys in tomorrow's session at morning 11:30 a.m. and it's going to be pretty cool tomorrow because you're going to be learning more about parallelism and threading, and it's very, very interesting to learn about that. So I'll see you guys in tomorrow's session, and until then, it's Bharat. Peace out. Like I usually say, have a super awesome day.